Good morning, everybody, and welcome to our pre-calculus class online. Um, Today, what we're going to do is we're going to continue on with lesson number 4 from chapter 5. Yesterday we talked about the loss of logarithm, and we it's just way too long, and it's just too much for one sitting and for one lesson. So I just kind of decided to cut off some pieces of it, and then we're just continuing on with that today. Um, so just to carry on with this, and this is going to be a short one, so we'll have a lot of time to work later. So example number 5, this is on page 21. Estimate the value of logarithm using benchmarks using trial and error. Now this one here, we did a little bit of that already in our using this one here. So we did trial and error here using exponential function. So we're gonna do the same thing in here. So just to kind of review again, the logarithm is really just looking for what exponent. Okay, so logarithm, I'm just gonna write it down. And it's always a good reminder what logarithm is. Logarithm is really asking for what exponent do I apply to base 5, to our base, which in this case is base 5, to get 7. Okay, so that's just basically what logarithm is. So, and it says here, we're going to use trial and error and then using benchmarks. So benchmark is something that we already know. So what do we know? We know that 5 to the 1 will give us 5, right? So the exponent log um, of base 5 to get 5 will be 1. Um, we also know that 5 squared is equal to 25. So this is 5. It's going to be less than 7. So it's a little bit lower than 7. And then 25, that's higher than 7. So we know that 5 to some exponent will give us 7. So we know from this, we know the exponent has to be between between 1 and 2. Okay, now what we're going to do is we're going to keep doing the trial and error. We're going to try some stuff. So I'm going to go 5 to the 1.1. Okay, I got 5.87. Okay, so that's okay, not quite 7. So let's do here 5.2. 5.2. Oh no, sorry. 5 to the exponent 5.2. What am I doing? So I'm 5 to the exponent 1.2. I meant. Oh, okay, we're getting super close. I'm just going to write it down so that I don't get. So 5 to 1.1. 5 to the 1.1 is equals to 5.87. And if I go, oh, okay, it's getting closer to 7. So let's go try 5, 1.2. So 5 to the 1.2, it's going to be 6.9. 0.86. Okay, it's getting really, really close to 7. So it's super close to 7. Um, and if I go to 5 to the 1.3, 5 to the 1 point exponent 1.3, I'm getting into 8. So we know we know that it's going to be close to 1.2. So let's go here. Let's go 5 point, sorry, 5 to the exponent of 1.21. 5 to the exponent of 1.21 is, that's really, really close. I'll just take that as my answer. Okay, so I figured doing trial and error, using trial and error, that the exponent that I have to apply to 5 is 1.21 to get a 7. So in this case, log, so therefore log of 7 base 5 is has to be approximately 1.21. Okay, so I'll just put a approximate sign there. Okay, that's just trial and error. Now let's try one more time using trial and error. So here, what we're looking for is exponent. What exponent do I apply to base 3? Okay, because this is the base 3 to get 5. Okay, so that's what logarithm is, looking for the exponent to figure out that we need to apply to 3 to get a 5. Okay, so what do we know? We always start with what we know. And that's what the benchmarks that they're talking about in here. So what do we know? Okay, we know that the 3 to the 1 will give us 3. But if we go 3 squared, that's going to give us 9. So 3 to the 1 will give us 3. So exponent 1 is not quite enough. Exponent 2 is a little too much. So we're going to go 3 to the exponent something will give us 5. And that's what we're looking for, that exponent. So we're going to try. We know from this, we know the exponent has to be between, again, 1 and 2. 1 and 2. Okay, so we're going to just keep doing trial and error here. So I'm going to start with, because it has to be between 1 and 2, probably closer to 1. So I'm going to go, what's 3 to the exponent 1.1? 3 to the exponent 1.1. So 3 to the exponent 1.1. Okay, so that's going to give me 3.348. Okay, so that's not quite the one that I want. What about 3 to the exponent 1.2? 3 to the exponent. My exponent button is y to the x. Yours might be x to the y. So yeah, different calculators have a different buttons, I guess. 3 to the 1.2, 3.73. Okay, so this is going to be 3.737. Okay, we're going higher, but we need to get to 5. So I'm going to go actually jump to 3 to the exponent 1.4. Let's see what that looks like. 3 to the exponent 1.4. I'm getting get closer. 4.655. Okay, I need to go up to 5. What if I go 3 to the exponent 1.5? 3 to the exponent of 1.5, 5.19, 196. Okay, so if I use exponent 1.5, I'm going to get slightly higher than 5. So I know I'm going to try this one here. So 3 to the 1.445. 3 to the exponent 1.45. Okay, so it's going to be 4.918. Okay, it's getting really, really close to 5. So I'm going to go 3 to the exponent 1.46 is 4.97. So I'm thinking that if I go 3 to the exponent 1.47, it's going to be slightly over 5. So we would say logarithm log of 5 base 3 is approximately 1.46. Okay, so and just by looking at that, answering those two questions by trial and error, it took us a long time to get it. Like it shouldn't, the trial and error stuff. Okay, so that's where the change of base formula comes in. And this is, let's just read this up. The change of a base formula allows you to rewrite a logarithm in terms of logs written with another base. This is especially helpful because it allows us to use a calculator to evaluate a logarithm. Calculators only have base 10, that's a base 10, common log, and a base E, natural log, programmed into them. So the change of base formula will let you change the base 4, for example, to a base 10. And this is what we need to, I'm going to highlight this. So this is, I'm going to put a star. That's important. This is a change of base formula. Okay. So it says here, if we are operating on a base A, okay, so base A, it doesn't matter what the base A is. It says here log of x base A. We can rewrite that as log of x base B, whatever the new B base is, divided by log of A base B. Um, Now because our calculator has, okay, and again, your calculator and my calculator might not be exactly the same, but you're gonna see if you look for the word log. So mine is right there. Yours might be, I don't have any other calculator besides this one, but look for the word log. And if you can't find it, you can send me a message and we'll try to figure out where the log is. But mine is right there. So this one here, log, is a common log base 10. Now over here, you'll see ln, mine is right in this key right there. Second function of 2. That's a natural log. That's for the base e. So what we can do is, if we want to use common log, let's say log of x base a, and we want to use a common log, which is base 10. We will just go here, log of x divided by log of a. Okay, so now from there we can calculate what that value is without using the trial and error. So let's use that in here. Oops. Okay, so use the change of base formula and your calculator to evaluate the following to 3 decimal places. So log of 15 base 2. Okay, I know that we're just going to use a log, change of log formula. So this is log, changing it to common log of 15. Okay, now I don't have to write down 10 there because it's understood we're operating in base 10 divided by log 2. Okay, now we can just do that on our calculator. So log 15 divided by log 2. So the answer is 3.907. 3.907. Now they're asking us to do 3 decimal places. Okay, so I'm just gonna do a quick check in here. This is a quick check just to kind of show you that it works. So if I go 2, okay, that's our base. And if I apply the exponent 3.907, okay, I should get very, very close to 15. Not exactly 15 because this is not the exact exponent. So let's try that. So 2 to the exponent 3.907, and I'm going to get, oh, look at that, 15.00. So approximately 15. Okay, so that one works. Now let's try this one. This one's an easy formula to follow. Log of 30 divided by log of the base 5. Okay, so log 30. So give it a try, and if you're watching right now and you're not getting the same answer as me, you can write a comment, and we'll try to figure something out on how to help you. Might be just locating the log button. So log of 30 divided by log 5. Oops. Log 5. And then the answer is approximately 2.113. 2.113. And let's just double check. Check if our answer makes sense. 5 to the exponent 2.113. Yeah. 5 to the exponent 2.113 is 29.986. So it's very, very close to approximately 30. And this one makes sense because we know 5 squared is 25. So a little bit more like a little bit over 2 will get us to the 30. Now let's take a look at the last one. So you can see it's super simple. So log of 100 divided by log 3. Okay, so log of 100 divided by log of 3. The answer is 4.19, and I'm going to round it off to 3 decimal places. So that's 4.192. Okay, and then just to, I know they didn't say check it, but just to verify if your answer is correct, let's see if this even makes sense. So 3, so what exponent do I apply to 3 to get 100? No, it's saying it's 4.192. So 3 to the exponent 4.192. It's going to get me approximately 100. Okay, so there goes our lesson. It's a really, really short one. So today is going to be giving you a time to just continue working, and it's very, 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 very important for especially for the next lessons that we're going to do in logarithm equations and solving exponential equation. Important to important to practice all of these questions. Okay, you got to practice all questions. Yeah, I don't want to put a thing there because that just looks like practicing those ones. Practice questions. Okay. Um, so this one will give you a time to work on those ones as well. Okay, as well. I just want to include as well. Please complete. Uh, please complete checkpoint 1 and checkpoint 2 on our booklets. On our book, not booklets, on our workbook. Okay. So there's checkpoint 1 and checkpoint 2, and just to let you know that tomorrow is the 17th. We actually have a PD day that day, so there wouldn't be any regular live streaming, regular class going on. So that would be an excellent time, a very perfect time to do all of the catch up practice that you need to do, and to also do the checkpoint 1 and 2. As you can see that we are nearing getting to the end of our chapter 5 booklet, so we only got a couple of lessons to go on logarithm equations and exponential equations. So our test will be coming up real soon. So I probably will tell you next week on when our test is going to be. So for the meantime, just work on these questions, and today and tomorrow to work on the checkpoint 1 and checkpoint 2 in our workbook booklet. And as always, if you have any questions or concerns, or if there's any practice questions from the book that you want me to go over, please send me an email, and I will go over it with the class, or I'll go over it with you. And yeah, hopefully that works and clarifies whatever question you have. So gonna leave that with you and wish you have a great day of learning today, and I'll talk to you again soon. Okay, goodbye for now.